Body's off the JK. We can take a closer look underneath. Pentastar engine still installed. This is really a massive engine for its displacement. It's only 3.6 liters, but look how large this motor is with all the hoses and tubes and other things that they have on here. Compare that to this LS3 on the ground. Much more compact engine. Alright, so let's look at a couple of things here. Rear section's pretty similar. Now this is the first time I'm taking a look at this, just like a lot of you guys, so I'm gonna take my best shot at what all this stuff is. They are running a fuel pump control module now in the JL, variable speed pump. This is something that GM and Ford and others have been doing for many years. Ford was doing it back in the 1990s. Basically they can control fuel pressure by changing the voltage to the pump, which raises and lowers pressure. We used to use fuel pressure regulators, negative and positive vacuum regulators, that when you got on it, the engine vacuum would go away and that would raise the fuel pressure a little bit and help the operating system cope with the injector pulse width. But the variable speed pump is a much better deal. GM's been running it for years. I do believe this is your tire pressure monitor module, so that's pretty similar to the JK. Now they have redone the evap here. Fuel lines look very similar to the JK. If we come up here, this smaller line is going to be our fuel pressure to the rail, and it looks like they're running a fuel pressure sensor now, which GM and others have run for many years. So they're really stepping up the technology of these Wranglers. This larger one's going to be our purge, so let's follow that up. And yep, we'll go right to our purge valve here. Coming back looking at some of this evap stuff, we've got our fuel fill obviously and our breather. Now this is going to be our fuel tank vent, it appears, and looks to me like it runs up into the fender well. My guess is going to be that's where our evap canister is. Now over here is essentially what used to be a C300 connector. That connector used to be up in the front next to the radiator. Now it looks like they moved it back here. So I don't know if they're running an ESIM. An ESIM is the evap system integrity monitor. It was a pretty poor system, and the way that it monitored small and large evap leaks was pretty primitive, but it worked. It does look to me like they fitted a fuel tank pressure sensor up here on the fuel filler hoses rather than down on the tank like they did in the Pentastar JKs. Again, not a big deal, just learning how the stuff works. I'll quickly mention this exhaust. It looks like it's very well made, very complex though. You got a ball joint here, you got a pretty complex Y here, you got stainless shielding on it. So let's look at the transfer case. Looks very similar to the old 2-speed transfer case. The Saharas do apparently have an option for an all-wheel drive, but I'm not a big fan of that. All-wheel drive transfer cases have a lot of parts in them, and I just like a 2-speed gearbox. Here's our transmission, which is the ZF 8-speed, and this is our transmission cooler. You can see that our tranny fluid comes in here to the cooler on this side and here, and then this is going to be our cooler section here that the water circulates through, and then of course this is going to go up to our tranny cooler in the front. Again, we can see the coolant leak, and you know, that actually looks like it might be a head gasket on this engine. Now good luck getting that warrantied out. Here's the exhaust outlet on the head, and you notice there's really no manifold. This goes right up against the converter, and that converter can run really hot. We're talking thousands of degrees. So if you consider that the valves are just on the other side of this, that's pretty concerning for me. I know Chrysler had some issues early on with death tick. We have our air compressor back where the JK had it, so that's going to be a piece of cake. Now it does look like they got a couple of connectors going in. This is going to be our AC clutch control. I'm not sure if this is pressure, if this is a variable speed control here, but we'll find out. The GM compressors are variable displacement, and they are controlled by the ECU in our builds. This is the power steering pump, the swimming pool pump we talked about earlier. This over here is our camshaft position sensors. There's actually 2 sensors built into this, one for each cam. There's one on this side and one on this side. So this is actually the sensor, and this is our phaser up here. And you'll notice that we have 2 phasers, one here and one here, and then there's the control, solenoid control for that. Very, very high-tech motor, this 4-valve dual overhead cam, and putting out 300-ish horsepower with 3.6 liters is really good. Got our crankshaft position sensor back here. Now in the earlier 3.8s, the crankshaft position sensor was in the transmission and the trigger wheel was on the flywheel. I'd much rather see the trigger wheel inside the crankcase where it's protected from dirt and debris. Here's that shield we talked about, and yeah, it does look composite to me. I do believe this little box that drops down as an auxiliary battery or a backup battery kind of makes sense when you have stop-start to have a redundant battery system. So it looks like they've incorporated that. That's going to be fun to replace. I'm guessing you have to either remove the fender well to get the battery out or the tip-em. Moving over here to the cables, I think this is probably going to be one of the biggest challenges. This is the transfer case shift lever. I don't see that really being modified too much. It looks like they went to a lever action. This, however, is the automatic transmission shifter cable, and it's very limited on its throw. I don't know a whole lot about the ZF transmissions, but from what I understand, this lever does not control shifting so much. And it doesn't really matter to me what it does because we don't have to work with it. However, we do have to have a functional shifter, so we've got several ways of approaching this. I've been told that this transmission only shifts when it has hydraulic pressure. I like to have full manual control of my transmission. I like to be able to put it in park and engage the parking prol. I like to be able to put it in neutral so the vehicle can be pushed or towed. I don't like to have the engine running to have hydraulic pressure to make the transmission function properly. But again, I don't understand the full operation of this ZF 8-speed, and I am very comfortable with the 8L90, so we're going to incorporate the 8L90 into this swap, which I think is going to be a big benefit. Now I will say that this transmission does a really good job with this 3.6 engine. Driving it for a few hundred miles, I really like the way this thing shifts. I think it does give the Pentastar better performance by keeping it as power range. Smaller displacement engines benefit from having more gears because they can stay in their power band more of the time. Larger displacement engines don't need so many gears because their power bands are broader. Let's take a quick look at this EGR setup. I'm not a big fan of exhaust gas recirculation. Growing up as an emissions inspector, EGR valves were always the most troublesome. Especially in the 90s, the passages would plug up and we get EGR codes, and cleaning out these passages, sometimes we had to remove the intakes and use cleaners, and it was just a very troublesome system. So it looks to me like what they've done here, here's our EGR valve, here's where the inert gases go back into the intake. We come down here, it goes into this exchanger. We are reading exhaust gas temperature here. This is going to be a cooler. This goes into our coolant system. This goes into our coolant system. And if we follow it around, there's just a whole bunch of hoses here that are just really complicating things. I'm really looking forward to cleaning all this up and simplifying the cooling system. Look at all the stuff on this engine. For a 3.6 liter engine, it's got a lot of hoses and wires and just a very complex setup. And I must say it runs good, but 5 years down the road, I'm not sure about the reliability of all this stuff. So we obviously got a MAP sensor here, MAP, and Chrysler has traditionally used a speed density system on the Wrangler, meaning they're not using actual airflow. Now I don't have the air intake here to look at, so I really can't tell you if this is running a mass airflow sensor, but I'm a really big fan of MAF sensors, because by using actual airflow rather than calculated, you can get more precise metering. When you go up to altitude, the MAF sensor can better cope with air density. The new Gen 5 LTs actually have a humidity sensor. So basing the fuel strategy off of actual airflow versus calculated, I think, has an advantage. Again, here we have a camshaft position sensor, and there are 2 sensors built into one. On the early JKs, these harnesses were too short and they caused some problems and some codes because the wires were being pulled on. We have all these connectors back here. Sure, we got fuel pressure, oil pressure, and a bunch of other stuff going on. I'm not going to spend a whole lot of time learning the operation of this. This is just a very complex motor, in my opinion, very high tech, and I'm looking forward to the simplicity of the V8. I'm going to spend a minute talking about the purge system. A lot of guys don't understand how it works, but it is pretty simple, and it doesn't really affect performance. We've got intake manifold vacuum here that comes right into our purge valve. So that's under full intake manifold vacuum. And this is where the vapors from the canister are going to be purged from. This is controlling the purge valve, and it's usually a digital signal. So it clicks when it runs, and the engine control module can control how much it purges. The early JKs did not have a closed loop feedback purge system, which means they didn't have a fuel tank pressure sensor to actually know what the pressure in the system was. They use an ESIM, an evap system integrity monitor, which is basically a switch to detect leaks. But the actual purging was done off of tables. I'm pretty sure that this JL is running a fuel tank pressure system closed loop feedback so that it can purge based on actual fuel tank pressure. Now, this is typical Chrysler, where I have a little bit of an issue. Let's look how complex it is to get the vapors from the evap canister to this purge valve. So we've got the purge valve here in the intake, and then we got this hose here with a couple of different clamps. Now you've got another hose here, which appears to be metal, which comes up to the front of the tank. Now we got another hose here, which comes back, and then we got another hose here, which goes back to basically some kind of a filter. Then comes out the other side, then it comes up here to the side of the frame, and then it goes up into the evap canister. That's a lot of parts to get the vapors from the can. Here we've got our vent hose to the evap canister from the fuel pump assembly. Here we got our breather over to the filler neck, which also has the fuel tank pressure sensor, or FTP. This is our fuel feed. So basically that's going to go up to the fuel rail and power the injectors. This connector here is going to be our fuel pump power, and I'm assuming the fuel level sensor. And it comes up here into this module, which I am assuming is the fuel pump control module. The ECM will change the output voltage of this module to power the pump based on the fuel pressure that it needs. The earlier JK fuel pumps ran an internal regulator, so they still ran a single line feed forward, but it was regulated in the tank. In the early days, we used to have regulators in the fuel rail. Problem with that was you'd pump the fuel forward, fuel would get hot in the rail, then it get pumped back and put in the tank, so the fuel in the tank got heated up, and that increased evap emissions. Single line system is the best. Variable speed pump is the best. Chrysler finally went to that with the JL. What we're seeing here is actually Chrysler implementing a lot of the same technology GM has been using for years. The fuel pump control module, the closed loop evap system. I remember back in the 70s and 80s, engines were getting out of control with emissions. There were hoses everywhere. We had all sorts of air valves and IACs and switching valves to control emissions and feedback carburetors. And you look at a Toyota from the mid 80s or early 90s, and there's just stuff everywhere. By the mid 90s to the 2000s, they really cleaned things up. Fuel injection, onboard diagnostics, sequential fuel injection with misfire detection, really cleaned these motors up. We removed EGR valves in a lot of the motors. Most of the engines got rid of secondary air. Primary air goes into the intake. secondary air goes into the exhaust. Secondary air is used to complete combustion and or feed an aspirated converter. But the engines got so complicated that we were seeing failures because there was that many more parts to fail. I feel like we got things simplified in the mid-2000s, and now we're kind of going back. We're going back to all the hoses and complexity. The law of probability states the more things there are to fail, the more likely you're going to have a failure. So I just see a lot of stuff going on with this JL engine. And we'll see how the reliability is in the long run. And I'm sure Chrysler's done a lot of diligence on keeping these things reliable, and they probably will be. However, I personally would rather see a more simplified powertrain. Not such a high-tech transmission, an engine that isn't as complex as this. And this is just my personal opinion. I had a lot of fun driving this JL. However, I just feel that this JL is too complex. Now you got to remember, this is a Wrangler. This is going to go off-road. This is going to be out here in the desert, 120 degrees crawling. So we've got a lot of stuff going on with this vehicle. The AC lines in these Wranglers has always been kind of a pain, and I like what they did here. What they did is they kept them tied up against the firewall, and they ran them along the fender well, and they bring them out over here. So that's going to help us out and everybody else out. Really, there's not a whole lot of design differences here from the JK. We got our heater hoses and our AC lines coming out at about the same place. We got our Tippmann battery about the same place. It does look like there's an auxiliary battery here. So the next step is we're going to be removing this engine and fitting the new engine. And I can say that when that's done, I have a feeling that this powertrain is going to look a lot smaller and cleaner, even though it's going to have far more horsepower than this powertrain. It's going to have the same number of gears, 8 speeds, but it's going to have quite a bit more horsepower and torque, and hopefully a lot more simplicity. Alright, now it's time for a little bit of a rant. This engine has about 600 miles on it, and you can see that it's got a cylinder head gasket leaking already. Now there's a fat chance that this engine's ever going to get warrantied out, but this just goes to show the more you have going on, the more likely something's going to go wrong. And not that any other motor couldn't have a head gasket leak, but I just think that this engine and this powertrain to me looks over-engineered. In comparison, let's come over here and look at an LS3. I think you can see, and the harness has been installed on this engine. This is our map sensor here. Just look at the simplicity of this versus what we just looked at. Here's our O2 sensor wires for the passenger side. This is our transmission connector, and this is a 6L80 241J. Come around this side here. This might be a good time to show you. Here's our alternator bracket for the LS3 and our air conditioning bracket. You can see that it puts the accessories right back where they were. Very similar hydraulic control unit and ABS module. 6L80 has a traditional shift lever, which I'm a big fan of. Simple tranny cooler lines. This is our clocking transfer case adapter. Simple 241J. Looks like they are running the same transfer case range sensor. This transfer case range sensor is used by the computers. It's actually run into the TIPM, and then it's used by everything in the network for ESP, light on the dash, you name it. So it's important that you have that in there. So if we look at the simplicity of this engine, and by the way, this vehicle's got our easy engine mounts on here. They're not bolted down, obviously. This motor was just dropped in. But there's no modification to the frame mounts with our easy mounts. So looking at how simple this engine is, putting out well over 400 horsepower, and then come over and look at this monstrosity, the differences are obvious. There's just a lot more parts and a lot more technology in this engine. The LT engine should rival, if not beat, the efficiency of this motor, and the horsepower potential on the LT engines is pretty much unlimited. You can get any horsepower level you want out of these new LT engines with direct injection. So we'll see you when this engine's out of the chassis.